Hello everyone. Today we will be taking apart this absolute monster of a calculator. It is the TI-84 Plus made by Texas Instruments. I often like to refer to this as the TI-84 Plus Original to differentiate it from the newer models that came along later in the TI-84 series. But anyway, this is a fairly basic graphing calculator. I mean, you can type in some stuff over there, and it'll graph it and stuff. And yeah, it's a pretty basic graphing calculator. But we're not here to talk about the calculator. We are here to talk about the internals of the calculator. And this calculator has 6 screws, 6 screw holes. And I have slightly modified this screwdriver to help better fit into these tight holes. I have ground away the edges of this screwdriver, as you can hopefully see as I tilt it along there. I did this by taking the pliers here and then just twisting it, which basically just shaves off the edges, because this metal is pretty cheap and flimsy, and it's not very, doesn't have a strong shear strength. I have already removed most of the screws, but not all, so let's go ahead and remove these 2 remaining screws. It's important to mention these are Torx screws, which have a special Torx bit. I guess it's possible to use a really tiny Allen key, or maybe a flathead screwdriver on these, but Torx bit is really the best. And I think the reason that Texas Instruments chose this is because they do not want these things to be easy to take apart. Whoop, lost the screw. So the last 2 screws are out, and now let's see if we can take this thing apart. Well, it doesn't seem like it wants to come apart very easily, but I think... Yeah, I have already taken this thing apart before, if it isn't obvious yet, but I feel like I can shove a screwdriver in this gap and then maybe twist it off, because there are some clips that are holding this thing together. So maybe I can insert it in there, and you know what, this might take some time. Well, that was a pain. Turns out I needed to remove the batteries and this door cover for the backup battery. So that was not exactly ideal, but I did in fact take this thing apart. So here you go. Well, we have an RF shield, and that's going to be a problem. So the reason that you have an RF shield over things is so that it doesn't transmit interference. And this is done to, well, I guess, appease the ham radio operators. There's not really any sort of practical benefit over having an RF shield, other than just blocking radio waves, which makes the ham radio operators in your area less annoyed. But anyway, this little thing right here is just a sticker, and this thing can come off. Ooh, circuits. So, what do we have here? There are 2 big chips. This one's got some marking on it, which says 07. This one right here is probably the main microcontroller. It says TI Ref 84 PLCR TA1 TU what dabba 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 do. I have no idea what this thing is, but whatever it is, it's probably pretty important. I'm also not really sure what this one is, too. I mean, I'd expect all of the circuitry to be condensed into a single chip, so why do you need 2 chips? That is very odd. And there's also this little piece of tape. Oh, that thing covers the connection to the LCD. Yeah, it's not... I shouldn't remove that. This right here is the crystal that regulates the speed of the oscillator that allows that allows the chips to work. But other than that, it's all just very generic circuitry, some transistors, diodes, some smaller chips, some capacitors, a larger diode and a larger smoothing capacitor, a tantalum smoothing capacitor so that you don't have to save space for a bigger electrolytic capacitor. Are these screws the same length as the ones that were on the RF shield? Yes, they are. Whoop. Hopefully I will not destroy the calculator by taking the main board off of the chassis. Sorry about that. Is that a 3 ohm resistor right there, or is that supposed to be some sort of fuse? This little guy right here. I don't know. But anyway, I think the board should be able to be lifted up from here now. Oh dear, those are the keys crackling. Oh no. Alright, so... Oh, okay. So the PCB is... the LCD is mounted directly on the board. Here are all of the contacts for the key switches. Here is the board. And all the keys are still on it. Oh no, this is going to be a disaster. I need to put this board out of the way. And let me see if I can remove this without losing all the keys. Oh boy. Oh yeah, those are all the keys, if you can see this. Yeah, these keys can be popped off. This one right here would allow you to type in your equation to the graph, but yeah, it's interesting. Maybe I can put all these keys back in their correct spots. I'm not really sure if these things, well, obviously they were designed to stick to everything. So yeah, I'm playing with fire right here, playing around with these keys. It's going to be a pain to put this thing back together, especially for some of these keys for the various functions of the calculator that I don't have any idea of what the correct arrangement for those keys would be. But yeah, all of the keys spilling out is definitely not an experience that anyone needs to go through. Maybe I can put this thing back. You know what, I should probably just put all the keys in the correct spots and then I can put this thing back. So I have put all the keys back into the chassis. You can hear all that. And here is the membrane board, which has parts of all the switches on it, and it has these little contacts which press up against the contacts on the PCB, and that makes a connection. And these contacts are actually, they're coated in graphite. That's why they're black, and you might be able to make a mark of it on it if you rub it on a piece of paper. But anyway, I hope I did not permanently damage the keyboard, but hopefully by massaging it in, I can get all of the keys to make contact. Yeah, that's probably gonna work. Let's put the main board back on. Incidentally, I should say that this screen does not have a backlight, unfortunately, so you can't perform graphing calculations when you're on a transatlantic flight and it's completely dark inside the cabin and you don't want to disturb everyone by turning on your reading light. That's a very specific scenario, but it would still be very nice to have a backlight in this thing. Maybe I can, in fact, put a backlight in this thing. Hold on, let me try something. While I'm waiting for the soldering iron to warm up to make my test, I should also mention that the way that the battery compartment makes contact with the PCB is that the PCB has these two pads over here, and the battery compartment has these two terminals, which are spring-loaded, if you can see. And when you press it against the pads, it makes contact with them, and you get a contact. So you don't have to have wires running through it that would be soldered to something and cause a large pain. Oh, and funny enough, I see a space for some electrolytic capacitors, which were omitted because I guess this tantalum capacitor could substitute for them. So these tantalum capacitors, they're much smaller and they're better than electrolytic capacitors in many ways. But of course, tantalum capacitors are insanely expensive, and I have heard that the mining practices for them might involve forced labor, so that isn't exactly a strong point of this type of capacitor. And electrolytic capacitors are, of course, much cheaper, and the people who make them are probably getting paid a living wage. I don't know what China's like, but without further ado, I think I need to continue on with my little test here. All right, so here's my test setup. I have a small SMD LED connected to a battery pack and with a resistor in series. And of course, here's the main board. And I think the place where you're supposed to inject a light signal would be from right here. So let's go ahead and align this little light up with this and see if the entire screen lights up. And no, nothing's happening. No matter how I shine this, I mean, only a part of the screen gets illuminated, which is a shame. So I guess I can't install a backlight into the screen. So that's sad, I guess. Well, I have screwed the main board back in, and the switches, they still feel normal, and I do not see any obvious errors in the way that I put back the buttons. It still looks normal, thankfully. But anyway, I just realized something. This little guy right here, this crystal that I mentioned before, it's very small and it's unmarked. And this type of crystal is usually 32.768 kilohertz, and it is typically used to feed a clock circuit that would power, well, a clock. So this thing would be used for timekeeping, and indeed, this calculator does come with a real-time clock. But I just realized that I completely glossed over this little component right here. And this one right here also is marked with the same sort of thing that this other one is. This one has X at the beginning. This one also has X at the beginning. And if we zoom in on that marking, we don't see much. B487000. This one right here is probably the actual crystal which controls the clock for these chips, because this thing right here is just the real-time clock that pulses the clock circuitry, and I mean clock as in an alarm clock and not as in the signal that tells these chips how fast to run. But this one right here probably generates the signal that tells the chips how fast to run, because this one is 48.000. This measurement is probably in kilohertz, and that would mean, or wait a minute, is it 48.700 or 48.000? All right, so it's a point and not a 7. Okay, so this probably means this thing runs at 48 megahertz, while this one runs at almost 33 kilohertz. So this thing runs orders of magnitude faster, and it probably is the thing that generates the clock signal for these two chips. Still wondering why this one is marked with 07. It almost looks like that they drew on it with chalk. Well, I mean, insert a joke about child labor here. Anyway, I need to put this shield back on, because otherwise the ham radios in my operator will get mad. So the RF shield is back. I don't think I mounted it correctly, but who really cares? It's an RF shield. Well, unless you're a ham radio operator, then you probably do care. But anyway, I need to now get the back cover back on so that this thing can have its batteries in and it can do its thing. So the case is back on, the batteries are in, it should work. Let's turn it on. Yep, it works just fine. And we can play some sort of games on it. Let's see, I think it was number sense, rational numbers, activities, and slide, yes, slide. Level bronze, and now we can play with fractions. So I think I definitely had a success. The calculator still manages to work just fine, even though that I took it apart, and yeah, it looks good. So, and I mean, its processor even works fast enough to run basic games like this. Apologies for the bad angle, it's just because the stand is in the way, but yeah, it's definitely working. I think we should call that a success.